All right, we'll go ahead and kick this off. If people come in late, that's on them. So everyone here for the wireless talk? Cool, a few hands. All right, so how many of you are students? A few of you, cool. How many of you are in the information security field, also now known as cybersecurity? All right, how many of you are wireless people? Hey, I've got 3, cool. All right, good. For the rest of you, you're here because of what? What drew you to this presentation? Title? All right, good catchy title is always important. I told you, I'll stand here and wait.
In 2004 call, that's funny.
Yeah? Yeah, you like that? Okay. All right. WPA 3. All right, cool. So brief agenda. WP what? We're going to talk a little bit, what does it mean? What am I talking about when I say that? So for everybody but the 3 guys who are wireless people, you may not know what we're talking about when we say WPA, right? We'll go into some technical details on WPA 3, talk a little bit about migrations to WPA 3. Is Wi-Fi 7 important? How many of you have heard of Wi-Fi 7? Cool. How many of you have heard of Wi-Fi 8? A couple of you? Okay. Some of you aren't into reading pre-standards RFPs. I don't know. I do leave time for questions, so I started a 45-minute timer because otherwise I'll talk for 3.5 days. And then I'll throw a slide up in case you want to connect with me. So let's just start with Wi-Fi protected access, or what WPA. What is it, right? First off, you'll hear me say wireless a lot because I hate Wi-Fi as an acronym. Why? Because it's a marketing term. I'm fine with it. People use it all the time, but it's a marketing term. It does official standards according to the Wi-Fi Alliance. It is Y-Fi. So you'll see it spelled Wi-Fi all lowercase, uppercase, all the rest of it, marketing terms, all the rest, right? But let's talk about where do we start. We started with WEP way back in 1997. And I always ask this, it is not picking on anybody in the room. How many of you were not born in 1997? God, I feel old. Right? 1997 WEP came out, wireless equivalent privacy, or wired equivalent privacy, right? So the whole goal was to have privacy for wireless, or RF, because it's going through the air, that's equivalent to wired when I plug in. So that was the goal of what we were trying to do. That's what WEP was for. So we saw that it was part of IEEE 802.11. Everybody know that that's the wireless networking standards, right? So we hear A, B, C, F, G, H, B, E, any of those kind of things. Pop quiz, what's PoE standard, Power over Ethernet? Power over Ethernet, IEEE standard, no? Yep, you got there, yeah, it's the dot, that's the important number. It's always fun because people are like, oh yeah, it's 802.11 BT for BT power. No, it's actually 802.3, so sorry, I do pop quizzes. So we're really looking here for privacy, right? Privacy of our data. How many of you understand what radio frequency is, RF, how it works, right? It's through the air. How many of you have heard wireless is way more insecure than wired? Come on, I know some people have heard that, right? Don't do banking over Wi-Fi, especially not public Wi-Fi, because it's insecure. Sure. You have to be more concerned at that point that your bank's security certificates aren't up to date. That's the bigger piece, right? But so that was really what we were going for. WEP is used CRC32 checksumming, right? So it's checksumming all the frames. Everybody understands a packet's L3, layer 3. Right, that's IP-based, frames are layer 2, it's physical, right, ish. How many of you know your OSI model 1 to 7? How many of you care about 5 and 6? No one, because nobody does, right? So we're doing it for privacy, so we're encrypting it, or encoding it with a 64-bit key in WEP. We're doing data integrity with CRC32. We do have authentication. With WEP, it's shared key only or open. How many of you understand that we still use WEP-based security today on all public networks that are open? Because open system is part of the WEP standard. It is not part of WPA, right? We'll talk about that in a bit. And it's shared key. So part of the problem we had with WEP was the shared key and the fact that it was using CRC and it was using insecure authentication or in the encryption standard. So I can capture it, and offline, I can take all the time I want to decode it. Once I've got that, I can capture that shared secret. I can then join the wireless, and I'm on. Right? So that's the fun. So we step into what went wrong. It's kind of what I just told you, right? I can come in here, the encrypted message, again, 64-bit key, going crossed. I can obtain that. I can then look up the WEP encryption key or crack it, right? And then I've now decrypted the message. I can sit there with an RF scanner. How many of you have flipper zeros? How many of you are lying that you don't have that you have a flipper zero, but you won't raise your hand? Yeah, you're out there. I understand. That's okay. So real easy. WEP became simple to crack. You can now do it on a flipper zero in a matter of moments if somebody wants to WEP and have fun with WEP. If you've got the Wi-Fi dev board and you want to have fun, there you go. So it's the bigger problem is stream cipher. So that key is repeated and repeated and repeated all the time. So it's easy to take offline and crack, right? So let's talk about WPA, Wi-Fi Protected Access. We brought that out in 2003 and we said, cool, this is gonna help. We're gonna fix this, except we're gonna use the same CRC and the same key length. So all the things that were problems with WEP were in WPA. So we said, okay, let's try that again. The year after. WPA2 was released in 2004, thus where I got the 2004 for my topic title, right? 2004 is WPA2. How many of you have networks today that are still using WPA2? I would say, so I work for Nexum. We're a value-added reseller in professional services. I do professional services for wireless. And I would say 80% plus of our clients still have WPA2-based networks, right? It's there. We still see it all over the place. And now we have to look at it, and that security is 21 years old. We start thinking about that. WPA2 now can drink legally. And as you can say, how many of you were not born yet in 2004? Come on, you can raise your hand, it's fine. There are people, right? So we have professionals entering the market that were born after WPA2 was released, and we still use that as our security. How many of you think nothing has happened security-wise on Wi-Fi since then? Yeah. Let's talk about attacks, right? So some of the big ones, you're going to see Van Hoff Pisons and Beck and Twos. They come into a play a lot here. They're security researchers specifically focused around RF, and then thus Wi-Fi falls into that. They have done most of these vulnerabilities in Wi-Fi have been found by these two groups of folks, right? They're prolific. If you read any of their papers, first your head will spin, mine still does, and then you'll get to the meat of it. And some of these things are really obscure, right? Some of these attacks, I have to have so much access to your network already that forget about the wireless, that's not my concern. I'm plugged into your core switches and I'm capturing all the packets on the back end too. And I'm injecting them, right?
Which is the dictionary attack, like the handshake capture?
So crack was a big one that popped that up because it was offline, some of the rest of it. Whole 96, 196 took effect and broke into, wow, just went out of my brain. Broke into the actual pre-shared key validation. So that's where a lot of it popped in, right? So I should stop going off my notes because then I forget where I'm at. Sorry. No, you're fine. You're fine. Ratified 2004. So the big part about it, two pieces that we took with WPA2. One, we went to CCMP for the encryption, and it's AES for, CCMP for the code validation and AES for the encryption standard. How many of us use AES encryption on any and everything that we do? Who's using MD5? Thank you. I've done that. People put their hands up, and I went, oh, let's talk. So yeah, AES. It was still an early version of AES, so we did see problems in it. And what we started to see were the attacks really take in, there's the pre-shared key. I don't want to go too deep, so if I go too deep, we'll be here all day. We start with the pre-shared key, PSK. How many have ever heard of that? How many have seen it written as password? How many have seen password 123? Because that's way more secure, right? So there's a four-way handshake when we go through this. I forget where, I think I had a diagram on it. Yeah, here we go. I'll go back. So we can start to see there's two types of WPA2. So that was the first piece. Now, do you notice what's not up here? I talked about it a minute ago. Open, right? WPA does not include open standards networks. Those are still part of the WEP standard. So all your public access Wi-Fi, Starbucks, Panera, most of those that you walk into, you see there's no lock next to it. That's an open standards network. That's actually using WEP-based security. Now, it does get a little bit more confusing these days, and we'll talk about why. But WPA2 brought us two things. One, pre-shared key, or WPA2 personal, and then WPA2 enterprise, which used EAP, or Extensible Authentication Protocol. How many of you have heard of EAP? How many of you have heard of stuff that goes after EAP, like PEEP? Heard of EAP PEEP? EAP TLS, EAP TTLS, EAP TKIP, EAP, lots of different things, right? These are all different pieces as they extend the extensible portion of the authentication. There's different ways to do it on the back end. We get into outer methods, inner methods, all these fun things that in a 3.5 day on Wi-Fi security we can talk about. In a 34 minutes left, we're not going to talk about, right? But the big thing to remember here is we split our authentication now. Pre-shared key, so password-based authentication, and enterprise. Enterprise requires a separate server. You see it down here called Radius. Everybody heard of Radius? 802.1x. Yep, same kind of concept. It all flows in. Yeah. So as we go through here, hey, there's my notes on this slide. So 2008, Beck and Twos down there could capture, and they could actually successfully send a few packets back onto the network that were accepted by the network. Everyone who doesn't know the four-way handshake of Wi-Fi? Who's afraid to say they don't know the four-way handshake of Wi-Fi? All right, cool. So association, right? I have to associate, I have to authenticate, and then I can get on the network, right? There's more steps in there. We're going to skim them, but they were able to send frames through the network unassociated with the network, right? So that's bad. That's the network saying, sure, I'll take those and transport them, even though you're not part of my network, right? So we had all of that. And really, what we started to see is most of these, there was an attack, and I don't talk about it because it's really old. How many have heard of WEP Chop Chop? No? No WEP Chop Chop? So that's, they chunk up things and they just keep throwing things at the network, right? If I just keep throwing things at the network, eventually it'll hit, also known as decryption attacks, because they're just randomly trying different passwords until they get the right one, okay? The problem we had with WEP was the security key length was fixed, and thus the encryption length and what you're using was fixed. So eventually I can find, by chopping up the frames, I can find what the key is. And then once I have that key, I can now interrupt and take over your session because I have your master key, pairwise master key, some of the rest of it. Any of this making sense? Yeah? Questions? And feel free, if you have questions, just raise your hand, shout them out. I'm up here. I will do my best to answer them. I'll make up answers for ones I don't know. That's what I do, right? So crack. Let's get down to crack. So if you look through these, take some time. If you're interested in Wi-Fi at all, I highly recommend going out, looking at some of these pages, understanding kind of what they do. If you're bored and want to fall asleep, read their studies. They're very academic, and they really dive deep into what they do. A lot of these, and we'll talk about it a little bit later when we hit some of the later ones, a lot of the attacks on Wi-Fi require access to other things and or time. So one of the big things we saw in WPA2 was they limited the number of times you can test a password or send a bad password, shall we say, right? So there's rate limits built in there that I can't just keep try ABC 1 2 3, ABC 1 2 3 4, ABC 1 2 3 4 5, right? And cycle through that. So that's part of what WPA2 brought us. We got the ability of being able to block people from associating after they try so many times. Now, that's where you'll see how many of you have gone somewhere where they have the password written on the whiteboard. It says join the network. Over there? Yeah. Isn't it great? But they do that, and you type it in, and it's like, oh, wrong password. You're like, oh, that was actually uppercase. Okay, cool. Type it in. Wrong password. Oh, that was what do they have here? Shelby Conf 2025, right? They wrote it really nicely. That's how you can tell I didn't write it. But you put in as a 2025 instead of 2025. Oh crap, that was wrong. So you try it 3 or 4 times, and all of a sudden, your network disconnects, right? You see the Wi-Fi symbol go dark on your laptop, whether it's a Mac, whether it's a PC, right? It kicks you off. You're like, oh crap, join it again, and it lets you keep trying, right? That's that security mechanism that they built in, that you can only have so many unsuccessful attempts against network before it says, yep, sends a disassociate frame, kicks you off the AP until you try again, and then it's like, oh, I forgot who you are. Yeah, keep trying, let's go, right? So there's a limit, but it really only breaks it when you're trying to automate that attack, right? Until you write a smarter tool that says, oh, hey, I've been kicked off, try again, right? Reassociate, and then keep trying. So what we started to see in these were we saw master lists of passwords go out. They started building for all the popular localized, we call rainbow lists. Anybody heard of rainbow lists? Anybody been to DEF CON and tried to find one? Who was successful? Can neither confirm nor deny. So yeah.
Wait, tell us what's rainbow list.
What's that? Rainbow list it's less important these days. They are still out there. They are still valid, and many of them still have successful credentials. But a rainbow list is basically a list of an SSID to a password. It's a password list. It's not a dictionary list where I'm going to try all the things. It's literally a list of, if you are in this location, join this SID, here's the password.
Do you find that in old DEF CON?
You might have found it in old DEF CON. You might be able to find it in new DEF CON. Just depends on who you know. No, so rainbow tables, rainbow lists, depends on what we want to call them, right? But the goal there is I'm going out, and it's literally just giving me a list for the passwords for all the wireless networks. It's great when I'm trying to break into wireless networks. So crack key reinstallation is a replay attack. So that's where we're taking and capturing, taking it offline, and then spitting it back at it until we can get back in. And we crack the session. We break into the session. I assume your session. So you join the Wi-Fi, you do all this. I'm sitting upstairs, and I'm like, I don't want to walk all the way downstairs and get the password, right? So I'm just going to turn my sniffer on. How many of you know that most Wi-Fi chipsets can listen as well as they can transmit, right? Anybody know the word for that? There we go. There's my Wi-Fi guy. It's also really important when I'm trying to do surveys. I need to do some of these things, right? So we do that. I can sit up there, I grab your packets, do the things I need to, run crack against it, run air crack against it, run any of these kind of tools that, how many of you think breaking into Wi-Fi is fun? How many of you think you're going to use it in your career? There we go. That's the way it's supposed to handle, right? I work with a lot of students, and they're like, oh, I can learn how to crack Wi-Fi. This is going to be awesome. And I say, absolutely. What do you want to do? What's the number one answer I get? Pen testing. Everybody wants to be a pen tester. Cool. Pen testing. Are you planning physical security pen testing? What's that? Right? Cracking Wi-Fi is fun. It's novel. It also doesn't happen for 90% of the people doing pen testing. You just don't need to do it. Honestly, I do engagements with physical security also. Sometimes they have a regulatory requirement that they have to have someone attempt to pen test their Wi-Fi, and I laugh. I'm like, okay, sure, we'll run the things. We have the tools, we'll do it. What are you doing? WPA3, EAP TLS, cool. We'll let it run for 10 minutes. We'll check the box. We're good, right? It is still breakable, as we will see, but for the most part, the encryption that's going around the RF, the encryption that's happening at the frame level, is these days way less important, right? What is the most important encryption standard in any computing across the network today? Where does it happen? TLS. Yep, it's happening all the way up at layer 7, right? HTTPS, the S is important, right? So again, if we go back to don't do banking across an open Wi-Fi network because it's insecure, well, but you're securing the actual communications all the way up at the application level, right? Between my web browser and that web server, that channel's encrypted. The fact that it drops down, goes then across a wired or wireless network, if they're capturing at the wireless network level or the wired network level, it's still encrypted data. Sure, they may be able to decrypt the data inside the frame, but can they decrypt what the data is that's in there? If they can do that, you're in way bigger trouble, right? So, lots of fun attacks we got through there. Like I said, I can do this all day. 2018, how many of you weren't born in 2018? 2018? Weren't born in 2018? All right. We're unalive in 2018. Let's go with that. If anybody raises their hand, I'm going to have some questions. Right? So 2018, 7 years ago, WPA3 was released. Why is this important? Because if we look, crack in 2017 was a huge thing. That hit all the wireless vendors started freaking out because this went across. This actually, where some of these were based on individual implementations of the standards, right? Everyone knows that a standard is only as good as the implementation, right? And we all know if we create a standard, there'll be 5 different versions of the implementation when 3 manufacturers implement it. When you get 10 manufacturers that implement it, you generally have 20 implementations of the same standard, right? We all like to pick on Cisco. I can say that. They're a partner. I'm allowed to. We all like to pick on Cisco because they all love to take a standard and make it the Cisco standard, right? So we run into the fun. But the problem was crack was actually an attack against the WPA standard, right? So the thing that underlie all of the wireless security across all the vendors. Now the vendors could implement individual patches for their specific system. There's this big problem you run into in IT security, which is people don't install patches. I do network discovery projects, we call them, which is where we go in and tell people what's on their network because they don't know anymore. Especially in manufacturing. The best one I've had was a version of Cisco switch code that was end of support, so full end of life in 2008. Was still active running on their network up until a month ago. So, you know, I can't complain too much. That's 2008. It's 4 years after WPA2, right? So WPA3 is the current version of the standard. What we run into, we still, again, have our enterprise. We now are up to 192-bit keys for the crypto, right? We're using AES 256 for GCM. We're using SHA 384. If any of these acronyms catch you, don't worry about it. You can find them online later and look them up. And we're actually mandating minimum standards. So what we had prior was we had standards, hey, you can implement up to this, but the minimum standards were still web, which was really crackable, right? So what we did with WPA3 is we said, hey, we need at least AES 128 on your encryption, which is a reasonable standard. Most of us these days are using much higher than that, but it's a reasonable version of the AES encryption standard. And that is in WPA3 personal, right? So we all know in the enterprise side, we like to bump the security up. We put it all the way up as high as we can. But on the personal, how many of you went in? Okay, it's probably a bad sample size. How many of your parents went in to their home routers when they got them and did anything? Yeah, right? They turn them on. Well, you know that most of the router vendors now actually generate their passwords because admin is a bad thing. It worked really well for me for many years. It was great. I don't know what the problem is. But that's why we started to see some of these changes. We're starting to see manufacturers actually secure their stuff. Same thing we see where, we used to have default accounts, default credentials that would get us into anything. Hint, there are still a lot of those still out there. So always check. But the other thing we do, so we've been saying pre-shared key, PSK, PSK, PSK. You'll actually stop seeing that soon. Anybody know what the next acronym of the day is? In WPA3, what are we replacing pre-shared key with? Anyone? Starts with an S. SAE, simultaneous authentication of equals. So in pre-shared key, we say, here's my password, let me in. It says, yes, your password matches. There's no authentication that I should be there. Simultaneous authentication of equals, SAE, allows us to actually do an exchange to say, yes, you're who I should be sending this password to. You're not someone bad, right? So we get that. They authenticate against each other. They generate additional keys. There's all kinds of fun steps here. Again, WPA3 is huge. The extra thing that we do, and this is where we get into some of the discussion we had. What are open systems? What authentication standard or wireless encryption and authentication standard do they use? WEP. We now have a opportunistic Wi-Fi wireless encryption, OWE, which is able to be used on open networks. What that does is it says, here's an open network, and this is vendor specific on how they implement OWE, but here's an open network. I join it, I associate. I'm able to log into the captive portal that works 60% of the time, and the other 40 I can't get on my hotel Wi-Fi. And when you're in the middle of nowhere, Tennessee, and your cell signal is 1 bar on edge, you're not happy as you try to get in and do real work. But pops up, it's then going to do one of two things. If there is the ability for both ends of the talk, right? Your access point and your compute device, whether that's your phone, whether that's your laptop, they will have a handshake and say, hey, can you encrypt? Yeah, I can encrypt. Cool, what encryption standard do you want to use? Well, we can try this one. Oh, that won't work. Let's try this one. It goes back and forth. So it's gonna negotiate an encrypted session. So it's actually gonna encrypt those frames now. It can, depending on the vendor, sometimes they shift you to a second network, which gets real fun with different system security. Other times they do other things in the background. All right, the key there is it looks like an open network, but after you're authenticated in there, it'll actually shift you to an encrypted channel, which is kind of nice. It gets around that thing that, oh yeah, that's open, so your data is all exposed. So anyway, the other big thing that we run into with WPA3 is we have this thing called protected management frames, or management frame protection if you're Cisco, because PMF versus MFP is, not confusing at all to flip that around. But with WPA2, you could encrypt them. So it said, hey, we can encrypt our management frames. Everybody, I'm not going to run through the list of management frames. Suffice it to say, exposed management is bad. I think we've all learned this at this point in time of our lives, right? Please don't put management interfaces on the internet. Thank you, Fortinet. Thank you, F5. Thank you, Palo. Thank you, everybody, right? Exposing a management interface to the internet is bad. Don't allow SSH through your firewalls. Make someone VPN in. Pro tip. But WPA2, we said, hey, you can encrypt these. And the vendors then had to say, hey, we're going to give you a little radio button that says encrypt these, that you're going to have to find 6 levels deep in the interface and check it, and then hope that the client supports it, right? In WPA3, they said, yeah, we're done with this optional stuff. Management frames have to be protected. They have to be encrypted. So there's a whole separate piece that encrypts those, that protects those management frames, because when your management frames are there, that's your association frames, that's your beaconing frames, that's how people find your networks, all those things, right? So just like exposing a management interface, exposing management frames is considered bad juju these days. So WPA3 2018, everything's perfect, right? We're done, we're secure, nothing's going to cause us any problems. Oh, hey, I should have done this slide earlier. WPA3, upgraded crypto, PSK replaced, protected management frames. And yeah, technically OWE is not part of the WPA standard, just like open network authentication, which isn't really authentication, isn't part of WPA. So, but you will see everybody talk about OWE as part of the WPA3 suite. And depreciation of EAP PEEP. You all knew EAP. How many of you have heard of EAP PEEP? One person tell me what's in EAP. What's the PEEP part that allows me to authenticate? What's in there? Credentials, username and password. Right? How many of you joined a corporate Wi-Fi network and it's like, hey, enter your AD credentials? Yeah, cool. Here's my username, here's my password. Cool. Yeah, that's crackable, so bad. Because now not only do I have your Wi-Fi credentials, I have your AD credentials. What happens when you're one of those folks that still don't have escalated privilege accounts or admin accounts separate from user accounts? I now have a domain admin account. Thank you very much, right? So EAP PEEP, and then we can get underneath it. There's MS-CHAP v2 that's part of the EAP PEEP exchange. That's the inner method versus the outer method. Again, time limited. Look it up, it's a lot of fun. But EAP PEEP, and what we saw was this is the depreciation of that is so that it's part of, how many of you have heard the word zero trust? How many of you know that zero trust is not a product that you can purchase? Okay, if anybody tries to sell you, I'm selling you zero trust, tell them to leave the room. I have done that. I had a vendor say, if you buy this, you will have a zero trust network. I said, get out. They went, no, I don't play those games. So EAP PEEP, what we get in there is we're moving away from username and password being a credential thing because it's able to be exposed, it's easy to crack, it's very easy to then use for additional things. So where was I? Oh yeah, WPA3, everything's perfect until 2019. We made it a whole year, unless you count the months. Dragon Blood hit. Another vulnerability that allowed us to break into and break WPA3. Frag attacks. How many of you have heard frag? No? Frag attack? All right. What's that? Yeah, it's fragmented attacks. It's able to do it. But this is the big one that is, you hear pop up, it's cyclical. It's like every 6 to 8 months, someone will pop up and say, did you know WPA3 is insecure? Yeah. They'll break up against it. Frag attacks hit. So they're design flaws in the Wi-Fi standard, right? So if we start looking at that, the fun with it is when you start looking and digging in, really it allows me to crack the WPA3 encryption, and the security patches were released. Again, all of our vendors, oh, hey, we're going to protect against frag, no problem, we'll patch, good to go. But the general guidance is just use HTTPS. Use secure at the application layer, and you're good. So that's really where the standard went to. It continues to be my number one guidance to everybody is when we start talking about Wi-Fi being susceptible to crack, there's one of two things they're doing. One, they're grabbing your data, generally considered bad. Two, they're gaining access to your network, also generally considered bad. How do we protect against these things? One, the data, sure, let them have the data. It's RF. I don't care, right? Because it's encrypted data, encrypted at a standard, encrypted at a level that they won't be able to crack it in a certain amount of time. Fine. They also, capturing Wi-Fi traffic is way more complicated than people think, right? There's these things called channels. I have to listen on the channel. I have to be able to grab generally both sides of the conversation if I really want to get, tricky on things. So becomes very difficult, especially as we start getting into higher frequencies, higher number of channels. We've got to have to scan them all. I got to find all that. So, but if I'm giving them, regardless of all of that, if I'm giving them data that's already encrypted at a higher standard, I don't care if you capture my data. I don't care. I SSL encrypt dang near everything coming out of my laptop, right? How many of you have heard of buy my VPN, it'll make you invisible, right? Thank you. All of the consumer-based VPNs that are fully not any security fun. So The other piece then is gaining access to the network. Okay, so they're able to hijack my session and they get on my network. So what do I do there? This is where Zero Trust actually can come into play. I have an architecture where I don't trust you just because of what network you're on, right? We used to have all this stuff that, especially IT people, we loved doing this. I did this for years. We loved putting you, hey, I've got to authenticate to the network. When I authenticate to the network, I'm putting you in the IT VLAN, and you've got access to everything, right? It's generally considered bad these days. We have this little thing called segmentation and or micro-segmentation, right? Do that on your wireless network, and then it's no different than a wired port. In fact, I have more luck on physical pen tests with an open port sitting somewhere in a conference room, the hallways are the best. I love it when they leave an unprotected port sitting in a hallway next to a chair. It's even better. Behind, everybody's putting up digital signs these days, right? Pretty things. It's really easy. It's a great way. I worked in that industry for 10 years. My first pen test engagement when I came to Nexum was to break into a digital signage network, and I said, oh, goody. All those things I was dead scared about for the last 10 years, I get to do now. The guy who, our head of assessments, he looked at my list and he said, I never would have thought of half of these. I said, I've been deadly scared about these. I ran digital signage networks for Fortune 10 folks, and things like, well, all they got to do is capture the video and then replace it with a small form factor stick and plug it into the network. And it's, in a lot of cases, those ports aren't authenticated. So they're now on the digital signage network. When you work in retail, sometimes those digital signage networks have access to the retail side of the network. I was very, very careful with all of my clients when they said, hey, we're going to give you access. We need you to have access to this pricing data, so we're going to give you access to the POS network. No, you're not.
What is digital signage?
Digital signage is taking a TV and making it into a pretty advertising board. How many of you have been to McDonald's? It's okay, you can raise your hands. We can also go with Taco Bell, Wendy's, Burger King, Chick-fil-A sometimes, any of that, right? You walk in there and the menu board now is a TV that rotates, does all that. Yeah, that's digital signage. It can be end caps. It can be, how many of you have gone into a grocery store and they have digital price tags? Yep, that all counts. So, I don't know where I got to for there, but hey, more attacks happen. So again, the key here is give them data that's already encrypted. So that way, if they sniff your packets over the air, which is easy, again, it's easy to do. It's not easy to get everything, especially if the person's walking around. But let them have packets that are encrypted, fine. Give them, hey, if you guys want to take 300 years to decrypt this packet so you can see something, that's on you. We can talk about post-quantum encryption over here later. Then the other thing, if they get access to your network, what can they do with it? Hopefully nothing. That's why we don't have domain admins anymore, right? That aren't protected and escalated and tracked, right? Yeah. Yeah. I still have full admin access. Shh. Let's talk about migration. How many of you came because you wanted to hear how breakable Wi-Fi is? How many of you came because you want to hear how not to let your Wi-Fi be breakable anymore? Cool, a few people. I've done this and people are like, yeah, I'm not here for the second half. Okay, cool, see ya. 7 minutes. Migrating. I'm going to make this quick. You've got 3 pieces: WPA3 Enterprise, WPA3 Personal, and OWE. OWE is not technically part of WPA, but it is. WPA3 Enterprise. It's ultra low risk. Do it. Turn it on. On your Wi-Fi networks today, assuming your Wi-Fi network is from the last 10 years, or 7 years as the case really is, turn it on. It's safe and easy to enable. You can enable what's known as transition mode. We'll talk about that here in just a second. But WPA3 on enterprise devices, especially your MDM managed devices, turn it on. If your laptops are more than 7 years old, people are complaining about other things. When you kick them off the network, it gives you a reason for them to be refreshed. But most of your things, I've actually tested, I used to have the spreadsheet in here, but it takes too much time to explain. But I've tested down to like iPhone 6s, and they can support WPA3. It's kind of fun. So safe and easy to enable. Generally, it literally is a checkbox. Now, the fun you have with that is, how many of you are still using Eat Peep? Yeah, you can't enable WPA3, which you should be moving to Eat TLS at least, which is certificate-based authentication. If you're not doing that, that's a bigger thing. WPA3 personal, low-ish risk. The reason it's only low-ish is because how many of you replace your laptops every 3 to 4 years at home? Yeah, I've got a 12-year-old MacBook that's still running great, by the way, doing things. So the problem we run into with WPA3 is if the client doesn't support it, right? So if the client doesn't support it, you'll see a couple of things. One, it won't see the network, right? Or two, you'll go connect and it won't be able to join the network, right? Generally, it's one of those two things. The older devices, the other devices we run into that have problems, how many of you love your smart home devices like I do? I have 173 smart devices at home. There's a very, very small percentage of those devices that can handle WPA in general, let alone WPA3. So you kind of have to keep an eye on that. Transition mode we'll talk about in just a second. MPSK, or multiple pre-shared key, how many of you use that on networks? It's where you have one wireless network / SSID that can have multiple passwords. No? Nobody? Wow, normally I get at least one. Really cool tech that relies on breaking WPA2 to be able to do it. But what it allows me to do is all those stupid IoT devices that can only take a password to join a network, I can now segment on the wireless side of things because they each get their own password. That way, if someone gets that password, all they can get to is what that password has access to. And I can still then do client isolation. This works really well. You'll see this. You may not even know you're on an MPSK network until you go to, say, a multi-unit dwelling, right? An apartment complex that says, we provide you free Wi-Fi. And you all get your own network. Meaning, you all get your own password, but you join my residence kind of thing. So MPSK is great. I use it with a lot of clients. It is reliant on WPA2 still, because WPA3 says, yeah, we can't do these things, guys. So MPSK is limited. OWE, low risk. This is probably slightly out of date, but you probably need to use transition mode due to device support. OWE, what you'll see is, for the most part, most of the vendors enable it as an add-on. So devices that can do it will, but if you enforce OWE on the network and the device doesn't support it, like 90% of the IoT devices out there, it will break. They won't be able to join the network at all because they don't understand those additional pieces for the encryption. WPA3 and Wi-Fi 7. So Wi-Fi 7 essentially requires the use of WPA3. They're tied together. Just think of it that way. It's a lot easier than all the fun things. The reason it's not just Wi-Fi 7 that requires it is because technically you can do Wi-Fi 7 without WPA3 in some ways. It's messy. Don't recommend it. But you also see WPA3 required for 6 gigahertz. How many of you know 6 gigahertz? Understand what it is? Yep, you're all in the US here, so it's easy for me to say it's a crap ton of extra bandwidth available, gives us way more channels. It does not mean we can go way faster on our Wi-Fi. They're not one-to-one. It does, however, as a side benefit, mean we may be able to go way faster on our Wi-Fi. You need WPA3 for Wi-Fi 7, but you don't need Wi-Fi 7 for WPA3. So I'm here to tell you today, on this slide, start going to WPA3. I don't care if you're still running Wi-Fi 5, depending on your vendor. If you're running Wi-Fi 6, if you're running Wi-Fi 6E, 6E, you have to have WPA3 to work 6 gigahertz. You have to. It's mandated, right? So 7 picks that up. So start moving to WPA3. I have clients that are like, I want to be ready. We're doing brand new system. I need to revamp my Wi-Fi so I can do Wi-Fi 7. I'm like, awesome. You're still using Eep Peep on your wireless. We can absolutely put in Wi-Fi 7 APs. They will operate the exact same as your Wi-Fi 6 APs you have today. But wait, why would I spend all that money? How about we get you on WPA3 and then you spend that money, right? No more eat peep with MS Chat v2 for your 802.1x. Blended security generations can lead to roaming issues. We'll talk about that here. I've got a few slides. They are for my friends at now HPE Juniper Networks. I borrowed Wes's slides because A, he did them and I don't have to. It's the only reason. How many of you are in IT that are not lazy? You're all lying. Yeah, I'm the only lazy IT guy, right? How many of you automate anything? Why do we automate it? Because we're lazy. So, this is a quick highlight slide. For those, it is being recorded, so you can grab this, you can take pictures. This is a distillation of a few different slides, but talks you through the different generations of Wi-Fi and then the generations of security. There's my 45 minutes, so we're going to go faster. But short version is it's an eyesore. I hate putting this up here, but it's really helpful later on when someone says, what's the difference? Mandatory security features of Wi-Fi 7, GCMP 256. So remember, AES 128 and CCMP was our minimum for WPA3. Wi-Fi 7 says, nope, we're going to take that up one more step, right? We're going to do beacon protection. That's our management frame protection or protected management frames, depending on your vendor. And then SAE GDH, so simultaneous authentication of equals. I forget what the GDH stands for, but that's our W3A personal. Packet captures. How many of you love packet captures? How many of you hate packet captures? Yeah. How many of us love but hate them? So we'll be able to see if you capture those frames. We call them packet captures. In Wi-Fi, we're capturing frames, right? But same thing. You can actually see and hear where what our requirements are. So every Wi-Fi BSS, we're going to see GCMP 256. We're going to see things in the AKMs in the packets. If none of this makes sense to you because you're not a Wi-Fi person, it's okay. We're going to see authentication key management suites, AKMs. We're going to see SAE and some of the rest of it, right? For opportunistic Wi-Fi, we're going to see in the AKM list, we're going to see opportunistic wireless encryption. This is why old devices that don't support it break, right? So to speed up the ability for me to get on a network, a lot of the driver vendors, because we all know developers always catch all their errors, they log everything, and they fully document what they've done all the time. And security is a key for all developers, right? Yeah. What happens is the driver vendors, it used to be, they've gotten a little bit better, but they'd write in the number of AKMs, and they'd say, go to AKM 2. And I support 2 AKMs. So as soon as I add SAE, or in this case, SAE Group Defend, and I go to 3 AKMs, the driver goes, I don't know what to do with this. Throws out the packet. That's when you can't see the networks, right? Any of you ever tried to onboard or put a new IoT device in your house and you're just using the regular one and you can't see the network? It's like, I don't see that. Yeah, it's because of this. That's the problem. And the problem with IoT devices is, A, they're still using ridiculously old wireless chipsets because it costs them less money. And 2, their drivers are holier than Swiss cheese. Wi-Fi 7 roaming. Wow, that's really hard to see. I thought I'd fix that. Oh well. Again, another eyesore chart. I've got a couple slides of them. The short version here is, if we go Wi-Fi 7 to Wi-Fi 7, all good. So if I'm roaming between Wi-Fi 7, how many of you have ever worked for an employer who said, well, we don't have money to replace the entire wireless network in this building. We're going to do it floor by floor. I'm totally fine with that. How many of you have had it where they say, well, we're going to replace those 3 APs because that's the money we've got for, right? So that's where this roaming stuff becomes important. When we look at Wi-Fi 7, 7 to 7 is almost always, and this can be vendor to vendor also. When we're doing that, and you'll see why, GCMP 256, PMF, mixed roaming. This is where we go from 6 or 6E up to Wi-Fi 7. Yellow's bad. Even more yellow than the screen is yellow. Bad. right? So we start to have failures on the roam. What does that mean? It means when I walk over here and I'm on my voice call or my Teams call or my Zoom call or my whatever, Google Meet or whatever, right? FaceTime, all those things, it'll stutter. And then generally they'll keep walking and it'll be fine, right? What does that mean? That it means the device had to go through the full four-way handshake and re-authenticate to the network. If your Radius server is really slow and or your DHCP server is really slow, that can cause worse outages. You can drop from the call, all those fun things. Promise we're getting close to the end. Mixed roaming, so 6E to that. The key here is what we have to look at, and honestly the bottom level, I can't think, I'm not highly caffeinated enough. I've only had 6 cups of coffee today. The big thing is, if we look at those charts and look at where the problem lies, it's when we have to change encryption standards. That's the problem. So if you can bring your Wi-Fi 6 network up to GCMP 256, and your Wi-Fi 7 network is mandated at a minimum of GCMP 256, you're going to be okay. If you have to go from GCM 128 to GCM 256, the encryption standards don't match. They're going to have to re-authenticate. You're going to notice it. Your clients are going to notice it. And that's generally for us Wi-Fi engineers, when the clients notice something, that's bad. So we try to not allow that. TLDR, turn on WPA3. So the whole last 50 some odd minutes of my talk is boiled down to these 2 points. Enable WPA3 ASAP and use transition mode if needed. I didn't really talk much about transition mode, but basically it's a checkbox on almost all the vendors that says WPA2 is okay because I'm allowing it for this transition time. What is the problem with that? If I'm allowing WPA2, I'm allowing WPA2, right? So that session now is brought down to WPA2, which is the whole reason why we turned on WPA3. So I'm essentially saying, yeah, it's okay if you break my security, it's fine. Went through all this work, it's fine, it's fine. We're just gonna allow it. Questions? That's it, that's the fire hose. This is the 55-minute version of this thing that could take 3 hours, right? If we wanted to dive deep. If you want my slides and you don't want to watch the whole recording, drop me a note, I'll send them to you. Here's how you can get in touch with me. Wow, that looks really bad yellow. That's where I am. It's a little bit about me. My LinkedIn is down here. My name is spelled weird, so it's generally really easy to find. And then I do have a blog down there. It's NetSec Plumber. So Nexum is a security company. I'm the infrastructure guy, so I'm all about the plumbing. Thus, network security plumber. Cool. Questions, comments, concerns? Otherwise, yeah.
Have you used a Wi-Fi pineapple?
I may or may not have used a Wi-Fi pineapple in my day.
Did you pre-order the pager?
Maybe. Can neither confirm nor deny the tool set that I may or may not carry on a daily basis.
You went to DEF CON this year, they had the pagers, they were like samples.
Yeah. I didn't make it to DEF CON this year. I made it last year. It's a load of fun. Go to DEF CON if you want to have fun. Unless you're one of those really uptight corporate folks, and then go to Black Hat and skip DEF CON, because DEF CON's not going to be much fun for you. DEF CON is the fun you make of it, hands down. Cool. Thank you much. Appreciate it.